Hi everyone. So this video explains what's happening in a NAND gate. So a NAND gate is basically it's the opposite of an AND gate. So an AND gate would be that if you pressed switch A and switch B, so here and here, then a light would turn on or the circuit would be complete. But a NAND gate means that the circuit is going to be complete. This LED light would turn on if um, you didn't press A and B at the same time. So basically, the only time it wouldn't be on is if you pressed both buttons at the same time. If you didn't press either button, it would be on. If you pressed one or the other, the light would still be on. The only time it would not be on is if you pressed both. So what's going to happen is current is always going to flow from the positive terminal to the negative terminal. So it's always going to flow out of the battery from the red to the black. So what happens here is current flows along this line and it goes through this heat sink, which I don't really know much about. But basically it goes through this heat sink and it goes to what we would call the positive, the hot rail, which is where current flows. So current's going to flow through this hot rail and it's going to hit this first node where it's going to turn through and go through this wire. And basically the current is always searching for, it's flowing from positive to negative. So it's going to the negative or going towards the black wires. So that's always its goal. So it's searching, trying to get to the black. So it's going through here and it has to go through this LED light, which lights it up and then comes back around and now it happily finds its way back to complete the circuit. So it's going from the red and then up through around here, lights up the light and comes back. Now, in the meantime, current is also going to continue to flow this way. And that's because even though some is going to split off and go and light up this light, it's kind of like water flow. So if you had one pipe leading into two pipes, then the water would split off and go into two separate pipes. So same thing as current through a wire. Some is going to go down this way and some is going to come this way. So now this portion of the current is going to go through this red wire. And then the breadboard, the way it works is current flows vertically through this middle section. So it's going to vertically flow to switch B. And if switch B is turned on, then it's going to flow through switch B. And it's going to flow through this wire and through this resistor. And it's going to come up through here and turn on this transistor, which is exciting because it makes that transistor into a conductor. So it's hitting this, what you call the base of the transistor, and it turns it on. Now, also, the current's going to go through this red wire, and if A is also pressed, then it's going to go up through here, and it's going to come down through this resistor, and it's going to turn on this transistor. So now we have two transistors turned on at the same time if you're pressing switch A and switch B. Okay, so why is that so great? So now we're pressing those buttons, and do those transistors, what are they really doing? So now let's look at this current again. I'm going to change colors. So originally the current was flowing down this yellow direction here, and it would stop here, and if these transistors weren't turned on, then it would just stop. It wouldn't be able to go because the transistors, if they're not conducting, then the current would just be blocked. It wouldn't be able to go through. So the current would just continue and light up the LED light. But if the transistors are conducting current, then the current's going to go through the transistor, and it's going to go through this transistor, and then it's going to happily go down this negative, down to the negative terminal here. So let me just show you that again. Up, down, and it's going to come down here, and then it's going to happily go back and complete the circuit. Now, the reason why the current goes this way and not through the LED is because these transistors now become conductors, so it's going to want to flow in this direction. It's not going to want to have to do the work to go all the way through this LED and light it up if it can just get to the negative terminal by just going through these conductors. So because it's going through those conductors, now it's not going to turn on the LED, but that's only if A and B are both pressed in this situation, and that's why this is a NAND gate.